Hello friends, in this video we are going to study the arithmetic instructions of the 8087 math coprocessor. We will study all the arithmetic instructions along with their examples, that how these instructions perform the arithmetic operations in 8087. So let us start with our topic. We know that the 8087 is a coprocessor, means that it is not the main processor but it works along with the association with the main microprocessor. So because it's a coprocessor, it doesn't mean that it will not have any of the circuitry. It will also have the same architecture. It will also have the bus control, the input output devices, and also the 8087, it has its own instruction set. Okay, now this coprocessor, that is 8087 coprocessor, it is paired with the 8086 or 8088 microprocessor. The 8086 and 8088 microprocessor, they will have their individual instruction set, and 8087 will have its own individual instruction set. Now, how to differentiate between the instruction set of the main microprocessor and the coprocessor? All the instruction of the 8087 coprocessor, they are having the prefix F. Okay, so in the mnemonics of all the instruction, we will have the alphabet F in as the prefix of all the mnemonics. So that is a point to note, that all mnemonics of the instructions in 8087 F as its prefix. Now this instruction, the 8087, it is having its own instruction set. So in this instruction set, we will have various types of instructions, and these instructions, they are categorized on the basis of the operation these instructions perform. Like there can be data transfer instructions, arithmetic instructions, compare instructions, transcendental instructions, load constant instructions, and processor control instructions. So all the instructions present in the instruction set of the 8087, they are categorized into different classes on the basis of the function performed by them. So here in this video, we will study the arithmetic instructions. These arithmetic instructions, they perform the arithmetic operations like addition, subtraction, multiplication, division, compare. All these arithmetic operations are performed by these instructions. So let us first start with these arithmetic instructions. First instruction is F, A, D, D. As I have told that 8087, all the instructions, their mnemonics will have the prefix F. Okay, just F is added and ADD is for the addition. Okay, its format is FADD, then destination, and then source. So what this instruction does, it is going to add the number which is at the specified source to the number which is there at the specified destination. So source and destination, those real numbers, they will be added. Okay. Okay, so the number which is stored at the source location, that will be added to the number which is stored at the destination location. Now source, it can be either a stack element or it can be a memory location. So directly a memory location can be specified or the stack element can be specified. Means that because we know that in 8087 we are having the stack. In stack we are having 8 registers. Okay, these 8 registers are labeled from 0 to 7. So any of these registers can be used. Okay. So source can be a stack element and or a memory location. But for destination, it is compulsory that it should be a stack element. So we can say that the result of this operation is stored in the destination, that is in the stack. Now, if in this instruction, if the destination and source, they are not specified in the instruction, then stack st is added to st1, and then stack pointer is so in this, if the source and destination they are not specified in the instruction, then st, that is the top of the stack, the top of the stack is specified in the st bit in the status register of 8087. So from there we will know that which register is the top of the stack. So that register is added to st1 and stack pointer is incremented, so that result is at st. So this is how this instruction is executed by 8087. Now let's see some examples of this. So these are some of the examples of this instruction. In the first example, you can see that F, A, D, D, ST2 and ST means source and destination both are specified. Source is ST, means the number which is stored at the top of the stack, that number will be added with the ST2, that is second pointer, okay, second stack element, and the result is stored in ST2 because result is always stored at the destination. Okay, after that, in the second example, you can see st5. Okay, fifth register will be added with the top of the stack and result is stored in st because result st is the destination. Okay, then FADD sum means it is representing a memory location. So the real number from memory, because here only the source is specified, destination is not specified. So real number from the memory is added with the stack element, that is top of the stack, and result is stored in the top of the stack st. Okay. Now, in the last example, FADD, both source and destination, they are not specified. So, when they are not specified, then stack, top of the stack is added with, then stack is incremented that is ST1 we can say. So ST and ST1, both these registers, they are added and result is then stored in ST. Okay. So these are few examples of this instruction FADD, which performs the simple addition of two numbers. Okay. Now, second instruction is FADDP. Okay. Now, in this instruction, there is also we are having the destination and the source. What this instruction does, it also does the addition. It is going to add ST, that is top of the stack element, to specified stack element. And then it is going to increment stack pointer by 1. Let's see its example. FADDP and then ST2. So just the source is specified. This ST2, it is added with ST and result is stored in the ST, and now again the stack pointer is incremented by 1. So in this, it is going to add ST2 to ST, increment stack pointer, because now the stack pointer is at ST. So when it is incremented, increment stack pointer. So ST2 becomes ST. The stack pointer is incremented. Now the stack pointer is going to point at ST2. So ST2 will now become the top of the stack. Okay. So that is the difference between FADD and FADDP. Okay, there the destination and source, it can be anything. It can be a memory location, it can be a stack pointer, means a stack element, it can be two stack elements can also be added. So there we have, if any options are available, but here the stack element is added with the top of the stack. Only the addition is performed between these two, means between the stack only. After that, we are having the third instruction, which is for the subtraction. So for subtraction, SUB is for subtraction, F is the mnemonic for all the instruction. Okay. So FSUB, destination and source. What this instruction is going to do? It is going to subtract So it is going to subtract the real number at the specified source from the real number at the specified destination, and it is going to store the result at the specified destination. So let's take an example of this instruction. So what this instruction is going to do? It is going to subtract ST from ST3, okay, and then it is going to put the result in ST3, that is ST. So ST is subtracted from ST3 and result is again stored in the ST3 third register. Another example is if FSUB difference is written. Okay, difference can be any memory location. So the real number which is stored at that memory location, that real number will be subtracted from the top of the stack and result is stored in the top of the stack ST. So real number from memory, it is subtracted from ST and result is stored in ST top of the stack. Another is the case when no destination and the source they are specified. In that case, ST is subtracted from ST1 and then result is stored in ST. Just like what the FADD, that is addition instruction, was performing, subtraction is going to perform in the same way, but it does the subtraction operation. Okay. So the next instruction for the subtraction is FSUBP. Just like we were having FADDP, here we are having SFSUBP. So here also destination and source are to be specified. But here the destination and source, they will be the stack elements only. Okay. So one of the stack element will be the top of the stack and the other will be the destination specified in the instruction. So this instruction is going to subtract the ST, that is top of the stack, from the specified stack element, and then it is going to put the result in the specified stack element. Then it is going to increment the stack pointer by 1. Let's take an example. So this instruction is going to subtract ST from ST2, okay, and result is stored in the specified stack element, that is result is stored in ST2, okay, and then the stack pointer is incremented by 1. So earlier the stack pointer is at ST, it is incremented by 1, so new stack pointer will be at ST1, okay. This is the new location for the stack pointer. So this is the FSUBP, just like FADDP was there. Okay. Now, these instructions which we have studied up till now, these instructions are dealing with the real numbers. Now, for the integer values, there are two instructions, one for addition, one for subtraction of the integer numbers. They are FIADD and FISUB. After these instructions, we are having the source. only source is required, no destination is there. Okay, so what these instruction does, these are for the I is for the integer. Okay, so this instruction is going to add the integer which is stored at some memory location to the ST, that is to the top of the stack. So integer will be taken from the memory location and it will be added to the ST. So source will be the memory location. Okay. Result is there in ST. If we see example of this, so F I A D D, and here we have given a label that is cars sold. So this memory location will be having that integer value that will be added to ST and result will be stored in ST. Just like that, we are having FISUB, so it is going to subtract integer number stored in memory from ST. It is going to subtract that number from the memory and it is going to store the result in ST only. Result is there in ST. ST, just remember that in the stack we are having 8 registers from 0 to 7 and any of these registers can be initialized as the top of the stack, that is ST. Okay, so ST we are referring to the top of stack which is specified by the status register bit. Example of this instruction is like FISUB and difference. So difference is the label given to that memory location. So from that memory location, integer number will be taken and that will be subtracted from the ST. Okay. So these are for the integer numbers. Now coming back again to the subtraction instructions, we are having F, S, U, B, R and then destination. Okay. So these instructions, they are just like the subtraction instructions which we have studied earlier, but the exception is that the contents of the specified source and the destination, they are calculated as the difference between them. Okay, let's see. So this instruction, they are similar to the subtraction instruction, that is FSUB. Difference is that it is going to subtract the contents of the specified destination from the specified source and put the difference in the specified destination. Earlier was the normal subtraction instruction, what they were doing, they were subtracting the source from the destination. Okay, now here destination is subtracted from the source, so that is the difference. R is for the reverse of this, that source is subtracted from the destination, but here destination is subtracted from the source. Okay, So here we will do the operation source minus destination, and the result of this will be stored at the destination. Okay. Now the next instruction is if SUB RP, then destination and source. This instruction is also similar to the instruction FSUBP. Okay, but the difference between these two instructions is that earlier the subtraction was from the source, is the destination is subtracted from the source, but now the source is subtracted from the destination and the result is stored in the destination. So what this instruction does, it is going to subtract the contents of source from the destination, and the remaining function is the same as the FSUBP instruction. Just the difference is that of R, that is the reverse operation. Earlier the destination is subtracted from source, but now the source is subtracted from the destination. Similarly, another instruction is FISUBR and then source. This instruction is also similar to FISUB, just this reverse operation, that is the contents of source are subtracted from the destination, that is the integer is subtracted from the destination or the source. Okay. So these three instructions, that is FSUBR and FSUBRP and FISUBR, these three instructions, they are similar to their corresponding instructions, but the difference is the subtraction of the source from the destination. Okay. So these instructions are for the subtraction operation. Next comes the instructions for the multiplication. So this instruction is for the multiplication. MUL is the mnemonic for the multiplication, and F is for the 8087 instructions. So here the destination and the source contents, they are multiplied with each other, and the result of this multiplication is stored at the specified destination. So what this instruction does? So the real number which is there in the source, that is multiplied by the real number from the destination. So source and destination, they are multiplied, and the result is put in the specified stack element, which is the specified destination. Let's take an example of this. So here F, M, U, L and then destination and source are specified. Source is the top of the stack and destination is the second register of the stack. Okay, so it is the destination. So ST and ST2, they are multiplied with each other, and the result is stored at the specified destination or the specified stack element, that is ST2. 2. Okay. Another example is F, M, U, L, S, T and ST5. So now ST5 is the source and ST is the destination. So again ST and ST5, they are multiplied and the result is stored at the destination, that is ST. Okay. So this is how the instruction FMUL is executed by the processor. Next multiplication instruction is FMULP, destination and then source. So here again the destination and source, they are multiplied with each other, but the difference is that now one of the where the result is stored, that is the top of the stack, that is at ST the result will be stored. Okay. So what this instruction does? So this instruction is same like FMUL, but here the difference is that the stack pointer is incremented with 1. Okay, means the source and destination, they are multiplied. Result is stored in the specified stack element, and after that the stack pointer, it is incremented by 1. Okay. Also, if in this instruction the destination and source, they are not specified, then one of the operand is the stack element, that is the top of the stack ST, and the another operand is the ST1. Okay. Let's take an example of this so it will be clear to you. So in this example, because in the instruction the destination and source both have to be specified. If any one of them is not specified, then the top of the stack, that is ST, is taken as one of the operand. So in this instruction the ST and ST2, they are multiplied with each other and the result is stored at ST. Now ST is the location where the stack pointer is pointing, that is the top of the stack. Now after doing this multiplication and storage of the result, the stack pointer is incremented with 1. So earlier the stack pointer is at ST. When it is incremented, the stack pointer is now at ST1. Okay. So now the top of the stack will be ST1. So that is the difference between FMUL instruction and FMULP instruction. Okay. One of the operand is the top of the stack, that is ST, if the destination and source, they are not specified in the instruction. Okay. And after this result storage, the stack pointer is incremented with 1. Now next instruction is FIMUL source. So in this instruction, the integer number that is stored at some memory location, that is multiplied with the top of the stack, that is ST. So this instruction, it is going to multiply the integer number which is at the memory with the ST, that is top of the stack, and the result will be put in the ST. How? Let's see an example of this. So this is the example of this instruction, FIMUL, then D word pointer BX. Means BX is a register. This register is pointing towards some memory location. Okay. So integer number, and this memory is pointed by the BX register. Now this integer number is multiplied with the ST, and result of that will be stored at ST. Okay, so in the earlier instructions, number was there in the source in the destination, but now in this instruction, the one of the number or one of the operand is from the memory. Okay, and that memory will be pointed out by some register. Okay, so these were the instructions for the multiplication operation. Now comes the division operation. For division, the mnemonic is DIV. F is again for the 8087 instructions. So this instruction is going to divide the destination by the source, and the result is stored at the destination. So at destination we are having a real number, at source also we are having a real number. So destination is divided by the source, and the result of this operation is stored in the destination. Example of this is F, D, I, V, ST2 and ST. So ST is the source and ST2 is the destination. Okay, so divides the destination by the source. Okay, so it is going to divide ST2 by ST, and result is stored at ST. So this is how this instruction is executed. Next division instruction is just like for the multiplication and subtraction addition. In these instructions we were having FADDP, FSUBP, FMULP. Just like here also we are having FDIVP. Okay, so this instruction is also going to divide the destination by the source, and then it is going to increment the stack pointer by 1. Divides the destination by source. Result is stored in, and another thing that happens is the stack pointer is incremented. Let's take an example. So here source and destination are there. Okay, so divides the destination by the source. Okay, so here the ST is divided by st2. Result is stored at st, that is top of the stack, and stack pointer is incremented. So this was FDIVP. So now the next instruction is FIDIV source. So here I is for the integer. You can remember this, that from I we can get that here one of the operand is the integer. Okay, so integer is that is stored at some memory location, that is multiplied with the top of the stack, that is st. Result will be stored in the st. Okay, so here divides st by the integer from the memory. Then result is stored in st. Okay, st is again the top of the stack, that is where the stack pointer is pointing. Okay, example of this is if I div, then percentage. Okay, so percentage, it is the label given to the memory location. Okay, so at that memory location the integer number is stored, so integer will be put from that memory location, that is from the percentage, and then it is divided by the st. Okay, and result is stored in st. So here the st is divided by the integer. Okay, and result of this is at the top of the stack, that is in st. So that is the instruction FIDIV. So for division we are having FDIV, FDIVP and FIDIV. Now the reverse operation can also occur. Okay, earlier the destination is divided by source, now the source is divided by the destination, just like we studied in the subtraction. Okay, so in division also for reverse action we are having three instructions: if div r, if div rp, and if I div r source. So these three instructions, they are similar to the instructions like FDIVR, it is similar to FDIV. FDIVRP, it is similar to FDIVP. And FIDIV, it is similar to FIDIV. They are similar to their corresponding instructions, but the difference is that now the reverse action is taking place. Okay. So earlier the source, the destination is divided by the source. Now source is divided by the destination. So only there is one difference between these instructions and their corresponding one, that the division process is now reversed. Otherwise the remaining function is the same. Here source is divided by destination. Here the source and destination, they are divided and the stack pointer is incremented by 1, and here the integer from the memory, it is taken and that is divided by the source. Okay. So these instructions are for the division operation. So we have covered the instructions on addition, on subtraction, on multiplication and on division. Now there are some other arithmetic operations also. So let's study the instructions on those operations. Like if we want to find out the square root of a number, okay, so next instruction F S Q R T, this instruction is to find out the square root of a number. So what this instruction does, contents of ST are replaced by its square root. So here the number whose square root is to be find out, that number is in the ST, that is top of the stack. So our operand is there, our operand is implicit, that is it is predefined. The number is there in the top of the stack, that is ST. Okay, suppose that in the ST we are having 4. So the contents of ST are now replaced by its square root. Okay, so if its square root is taken, so now the new contents of ST will be 2. Okay, so whatever number whose square root is to be found out, that number is first stored in the top of the stack, that is ST, and then we will use the instruction FSQRT. Okay, next instruction is for the scaling operation, that is FSCALE. F is again for the 8087 instruction, and for scaling the mnemonic is SCALE, scale. Okay, now what this instruction does, it scales the number in the ST. So scaling of the number which is there in ST is done. How this scaling is done? Adding an integer value in ST1 to the exponent of the number in ST. Suppose that at the top of the stack ST we are having the number. At ST1 we are having an integer. Okay. So that integer is added to the exponent of the number. So here exponent of number plus the integer. This is how scaling of the number is done. So this instruction is going to scale the number, and it is the fast way of multiplying the numbers with the integer of means in the power of 2. It is the fast way of multiplying the numbers. Now the next instruction is FPREM. F is for the 8087 instruction. PREM means P is for the partial and REM is for remainder. Okay, so partial, remainder. What this instruction does, the contents of ST1, they are subtracted from the ST over and over again. Means again and again the contents of ST1 they are subtracted from the contents of ST such that the contents of ST they become smaller than the contents of ST1. Let's take an example. Suppose that at ST we are having the number 54. At ST1 we are having the number 10. So contents of ST1 are subtracted from the contents of ST, that is 54 minus 10. We are getting 44. Again 10 is subtracted from this. We will be getting 34. Again 10 will be subtracted. We will get 24. Again we will see that 24 and 10 we will again and again we are going to compare it because again ST1 its contents are smaller than the contents of ST. Okay, these are the contents of ST. This is also contents of ST. This is of ST1. Okay, we have to find out that the contents of ST are smaller than ST1. Again 24 minus 10 we will get 14. Again 14 minus 10 we will get 4. So now at this point we will see that the contents of ST are smaller than ST1. So again and again we are doing the subtraction, we are getting the partial remainder. Okay. So this is how this instruction is executed. Contents of ST1 they are subtracted from contents of ST. So ST1 is one of our operand and another operand is there in ST. Okay. Next instruction is F R N D I N T. F R N D I N T. R N D is for round and INT is for integer. So what this instruction do? It is going to round off the number which is there in the ST to an integer value. Okay. So rounding operation is performed by this instruction and the number is rounded to a nearby integer value. And number is there at the top of the stack, that is in ST. Now how this rounding off is decided? In the control word, the control word of 8087, it provides the rounding control, that is RC. In that, we are having the round control bits. Okay, that is RC bits are there. So these RC bits are going to decide the rounding of this number. Operand, that is the number, is there in the ST. That number is round off to the integer value. And how the rounding is to be done, that is decided by the RC bits in the control word of 8087. Now next instruction, FXTRACT, that is extract. Okay, F extract. This instruction is going to separate the number which is there in the ST into its exponent form and the individual form. Separates the exponent and the significant parts of the temporary real number in ST. So at the top of the stack ST, there is a number which is a temporary real number. That real number is separated into two parts. One is its exponent and other is its significant parts. Now after this separation, the exponent, it is the significant parts are contained in the ST, and the ST1, it contains the exponent. So at the stack, at the top of the stack in ST, we are earlier having the number. After the execution of this instruction, it is separated into two parts, and after separation, the new contents of ST will be the significance part of this temporary real number, and ST1 is going to contain the exponent part of this temporary real number. Okay, so extraction is done, means out of the number, exponent and the significant part, they are separated out. Okay, next instruction, F A B S. ABS is for absolute. So what this instruction is going to do, it is going to provide the absolute value of the number. Again, the number is stored in ST. Now, whenever we find out the absolute value, suppose that the number is minus 24. After we are finding the absolute value, the number is going to change from 24. So what this absolute instruction is, it simply makes the sign positive. Okay. So earlier the number is there in ST. After the execution of this instruction in ST, we will have the absolute value. Now the next instruction is FCHS. Now this instruction, it complements the sign of the number which is there in the ST. So suppose that minus 24 is there, it is going to make it 24. If it is plus 24, then it is going to make it as minus 24. So difference between absolute and FCHS is that absolute is always going to make the sign as positive, whereas the FCHS, it complements the sign. Positive is changed to negative, negative is changed to positive. Okay. So these are the arithmetic instructions available in the instruction set of 8087 Math Coprocessor. Let's summarize these instructions, that how we can categorize them depending upon the operation performed. Like for addition, we are having some instructions. For subtraction, multiplication, and division. And there are some miscellaneous instructions also. We have classified the arithmetic instructions depending upon the operation performed by those instructions. For addition, we studied FADD, FADDT, FIADD. Okay. For subtraction, we studied FSUB, FSUBP, FISUB. Okay. And after that, we were having reverse instructions also. FSUBR, FSURB, RP, FISUBR. These are for the subtraction. For multiplication, FMUL, FMULP, FI, MUL. Okay. For division, FDIV, FDIVP, FIDIV. For reverse, FDIVR, FDIVRP, FIDIVR. Okay. Then comes the miscellaneous instructions. FSQRT for square root, FSCAL for scaling, FPREM for partial remainder, FRNDINT for rounding the to integer value, then FXTRACT for extraction, FABS for absolute, and FCHS for complementing the sign. So we have studied all these arithmetic instructions and we have classified them depending upon the operation performed by them. So it will be easy for us to remember all these instructions and to remember that what operation or how these instructions are executed. We can summarize them like for addition, subtraction, multiplication, division. This is the simplest addition or subtraction or the simplest operation between the source and the destination. P means that source and destination, they are added, subtracted, multiplied and divided. Difference is that the stack pointer is incremented by 1. In FI, whenever I is involved means that the integer number is there from the memory, and then ST is the operation is between the ST and the integer number from the memory. If R is there means reverse operation is to be performed. Okay. Then miscellaneous, we can remember them by their mnemonics, that what operation they are performing. So it will be easy for us to remember that remember all the arithmetic instructions of the 8087 math coprocessor. So I hope that this topic is now clear to you. Thank you.